Lesson 13, Substitution and Area of an Isosceles Triangle. Why don't you go ahead and pause your video and write down these steps for solving a system of equations by substitution. Number 1, isolate a variable in one equation. Number 2, substitute that variable into the other equation. Number 3, solve. Number 4, substitute the value of the first variable into an equation and solve for the second variable. And note that we need to write your answer in the form of a coordinate pair, so x comma y in parentheses. All right, example 1, use substitution to solve the system x equals y plus 5 for the first equation. The second equation is 3x plus 2y equals 5. So the first thing we want to do is look to see if we have one of the equations that solve for one of the variables. And that first one, in fact, is. It's already solved for x. Therefore, we're going to take that expression for x, y plus 5, and we're going to substitute that wherever we see x in the next equation. So in the next line, the x is replaced with y plus 5 because that actually equals x, as we see from the first equation. So distributing the left-hand side, and combining our y terms and our constants, subtracting 15 from both sides, and dividing both sides by 5. We get a solution for y. So we find that y is -2. So great, we are half done, maybe even more than half done. All right, now we have to go find x. You're going to take that value of y and you're going to plug it into one of the equations. So probably the best equation to substitute it into is that first one because it's already written in terms of x, and that's what we want to find, right? X equals what? So that first equation, we're going to substitute the y value in place of y. Simplify it up, and we get x equals 3. So great, we have x and y, and remember our answer needs to be expressed as an ordered pair. So 3 comma -2 in parentheses. Example 2, we're going to solve this system of equations by substitution. So unlike the first example, we do not have one of our equations solved for a variable. So we want to examine our terms here, and we're really looking for something like this. So a single variable with a coefficient of 1 or -1. All right, so let's rewrite this equation. Let's solve this for y. Y is negative over here, so I really want this to be positive y. I'm going to move that to the other side. Remember the concept, change sides, change signs. So all I'm going to do is I'm going to put y on the right side, and I'm going to move the 11 to the other side. Okay, I'm changing sides, changing signs. So that first equation is rewritten as 3x minus 11 equals y. Okay, and now we have an expression for y. In that second equation, we're going to substitute anywhere we see a y. So here we go, 2x plus 3, and in parentheses, that's where I'm going to put my y value, 3x minus 11. All right, let's simplify this up. Distribute the 3 into the parentheses. 2x plus 9x minus 33 equals negative 11. All right, on the left side, we need to combine up our x's for 11x before we start moving terms to the other side. All right, let's keep solving. We're going to add 33 to each side. And we've got 33 positive and 11 negative. I believe that should be 22. And we keep going. So what is x? X is 22 divided by 11, which is 2. Great. Now we know what x is. So let's take that and find out what y is. All right, now as we stated before, we can plug that into any of our equations, right? Let's take a look here. Which should be the easiest one to do. We could plug it in anywhere, but really our best bet is going to be this one right here. This equation is from our first equation. It's just been rewritten though, hasn't it? It's already in terms of y equals, and that's exactly what we need. We need y. So starting with that equation, y equals 3x minus 11, go ahead and substitute your x value. So we have 3 times 2 for 6, 6 minus 11, which gives us negative 5. So y is negative 5. And then we're going to express our answer as an ordered pair. Okay, so x first followed by y. So 2 comma negative 5 and parentheses. You guys have to include the parentheses, all right? Otherwise, it's not an ordered pair. It would just be a list. All right, we're changing topics now. We're going to talk about the area of an isosceles triangle. So I just copied some text from the book here. We need to get some vocabulary words down. When we bisect an angle, we divide an angle into 2 angles whose measures are equal. When we bisect a line segment, we divide a line segment into 2 segments whose lengths are equal. All right, so look at this angle over here on the left. We've got ray YZ. So this ray right here, this bisects angle PYX. It divides it into 2 equal angles. So 2 equal angles. So this ray right here, ray YZ, is called an angle bisector. Bisect means to cut exactly in half. So that is the angle bisector. Over here on the right, we have a line segment. Okay, so point R, point R is the segment bisector. So what does that mean? It means that both of these segments are congruent or of equal length. Okay, so that's a segment bisector. So you should have a good idea about what a bisector is. It's anything that cuts something exactly in half, okay, into 2 equal pieces. So what does that have to do with the area of an isosceles triangle? Well, we can find the altitude of an isosceles triangle by drawing a line segment that connects the midpoint of the base. So find the midpoint of the base to the opposite vertex. Okay, so down here at the base, this is the midpoint, right? So it's the midpoint. So that means this base is cut exactly in half. And this pink line here, guys, this is called a median. This is a special word, okay? This special vocab word. The median of a triangle connects the midpoint of a side to its opposite vertex. So when you have an isosceles triangle, this median is also a perpendicular bisector of the base. Okay, so it bisects the base into two equal pieces, and the median also bisects the angle at the opposite vertex. So it's also going to give me two congruent angles up here. Okay, and we might use that at another time. So that's the structure of this isosceles triangle. So how do we find the area? Well, we know any area of a triangle is area equals what? Area equals base times height divided by 2. Okay, so if I take half of this guy, if I take maybe the right side, that's a really bad picture, sorry. Okay. If we take the half of this, we can tell what this half of the side is if we know the full base, right? We're just going to take half of it. But do we know the height? Do we know h? Do we know the altitude of that triangle? We do not. However, what you guys have, since we have the median is a perpendicular bisector, we have a right triangle, don't we? So we have a right triangle from which we can use the Pythagorean theorem to find h. So that's going to be step number 1 when you're asked to find the area of an isosceles triangle, okay? Number 1, use Pythagorean theorem to find h, the height. And then once you've got the height, just plug it into the area of a triangle formula, and you're good to go. All right, let's try one. Example 3, find the area of this isosceles triangle. So we're going to start by writing our formula. Area equals base times height divided by 2. All right, so the base, we already have the base, correct? The base is going to be this entire thing here, 4. And now we need to find the height. Okay, so sketch in the altitude of the triangle. Boom. We have a right triangle. Okay, label that H. So we have to go find that. So I'm going to take that kind of off to the side here. All right, so we have 3, that's the hypotenuse. H is altitude. And what's the length of this base here? It should be exactly half of the original base, correct? Okay, because that median is a perpendicular bisector. So our base here is 2. So, all right, Pythagorean theorem, here we go. So leg squared plus leg squared, my 2 legs are 2 and h, equals hypotenuse squared. All right, so simplify that up. Move the 4 to the other side. Take a square root, and we have the height is square root of 5. All right, so what do we do with that? That's what we needed for our area formula. So multiply that, 4 base times height, root 5, divided by 2. And let's keep going. Let's simplify. Oops, I don't want that color. Let's try a different one. Okay, can I cancel anything here in this fraction? So I can cancel the 4 and the 2 because the 4 is outside of the root. Okay, so you can cancel numbers that are outside the roots or numbers that are all inside the roots. So these cancel here. 2 goes into 2 once here, twice here. So the area is 2 root 5. We don't have any units, so we'll just say it's units squared. So guys, when you do these are no calculator problems that need to be expressed as reduced root, okay, or expressed in reduced root form. reduced root or radical, reduced root or radical form. Okay, what does that mean? If I have a square root, I have to reduce it down to simplest terms. And there you go, that's your answer. Area is 2 √5 square units.